Let's talk a little about computation methods. Numerate adults can work with numbers mentally or with written symbols. They can do this not only because they've had a lot of practice at it, but because our brains gradually become better at thinking abstractly as we get older. Most children, however, need visual images or even concrete objects they can touch and move around. The thing is, our students' individual comfort level with the abstract is different for each child. In a grade 7 or 8 class, for example, probably more than half of the students will benefit from having physical manipulatives to help them. Even in grade 9 or 10, I find a good portion of the class will find it useful, although more of the students can cope without, as long as I provide good visual representations. What this means is that virtually every maths lesson, and certainly when introducing or developing any new ideas, every maths lesson should include the use of concrete materials. Look for as many opportunities as you can to get different senses involved: visual, auditory, kinesthetic. Get your students active and involved as often as you can. But what about calculators? Modern technology has completely revolutionised the way most adults approach mathematical problems. Instead of pencil and paper, today we grab a mobile phone, tablet, even a laptop. We really do carry around calculating devices almost everywhere we go. A $5 calculator can do in seconds what our grandparents spent hours practicing to do in their mathematics lessons at school. And yet much of what happens in primary school classrooms has not changed. We still teach laborious written algorithms for the simplest problems. Even in middle school, we still require students to sit exams without calculators, to show us what they can do without a tool that, to be honest, most of us as adults wouldn't hesitate to use. Why? There are good reasons, don't get me wrong, but this issue deserves careful, serious thought. Our students need to develop a powerful facility for doing mathematics, not just the mechanics of particular algorithms, but with a deep understanding of how they work and the insight to select and apply the right strategy at the right time. To be truly numerate means knowing when to add, multiply, divide, not just how. What does the Australian mathematics curriculum have to say about this? The old Queensland syllabus said that students solve problems by selecting from a range of computation methods and strategies, including mental, written and calculator. The new Australian curriculum says students calculate answers efficiently and choose appropriate methods and approximations. How can our students work efficiently unless they learn and practice some reliable, efficient algorithms? And how can they choose appropriate methods unless they know some appropriate methods? Obviously they can't. So we do need to teach them some good, efficient and effective algorithms in a variety of modes, mental, written and using technology. But we also need to make sure that they encounter a wide variety of different kinds of problems and contexts, so they can get some practice at choosing methods and can learn which methods are appropriate when.